Howdy everyone, it's Miss Kosh. I wanted to work through today's notes on harmonic motion. I thought I had put a problem on the notes that I had already worked in previous years and I already had a video for, and then I realized that this problem is a little bit different than what my first video has, and I also realized that, and also I was having a hard time getting my Word document to save. So it would be really annoying for me to go try and redo this original problem. So here's my suggestion to you. My suggestion is that you watch that first video. Hopefully you've already watched it, and you take your notes on here's page 1 of the notes, page 2 of the notes. Take your notes on that one on page 3. That one is a little easier to understand, and then come back, and I have a video for number 2 already. I just redid the answer key, and then I'll talk about, I'm not sure if I have a video on number 3 or not yet. I'll make that one next. But then watch that other video, take notes on page 3, then come back and watch this. So I just put this little, this is going to show up at the beginning of your notes. So this is a little more complicated. The difference is that in the other problem in my first video, our point starts here and moves around the circle, and we're just concerned about point P. This problem changes things and talks about point E. So point E is down here somewhere, and so what's happening, I should have, dang it, I should have Googled this first. Well, too bad. What happens is this is hanging, this bar hangs, and so then as it starts rotating, it hangs down, it'll be 2 feet or 2 centimeters higher, so that's a little bit off on that one. But it's gonna be, this point moves kind of around as this bar, when it's here, it'll kind of hang down like this. When it's over here, it hangs down again, and here it hangs down a little bit lower. It's that sort of thing. What I was going to Google to show you what I was talking about is there's a ride at Chuck E. Cheese, if that is still even a thing. But basically, it's a clock, and the kid, I'll post a picture of in my answer key, but if you Google clock ride Chuck E. Cheese, it used to be a thing, and you can see as the clock turns, there's a bar hanging down that the kid sits, the seat's at the end of this bar hanging down just like this. I don't really want to go Google in the middle of my video, so sorry. But all right, so let's actually look at this one. The original problem that I did is a little easier because it's this point and it kind of goes around like that. This problem, we're talking about this point that is 10 centimeters. So this right here would be the point. It's the point to -10. And at the time, okay, let's see. Assuming that the center of the wheel is at the origin and P is that at time 0. Okay, find a function that describes the y-coordinate at time t. Okay, so this would be at time 0. And then they don't tell, it's coming, they did tell us that it's rotating counterclockwise. I can't talk. So it's going to do something like that. So then at time, at whatever time, then we have that this is going to be this is the coordinate 0, -8. Okay, do you see how that's hanging down? It's not hanging down quite as low. And then this one, we don't know the time yet. We're going to talk about that in just a second. But this would be the point -2, -10. And then when it comes all the way, it's gone up and around, and now that it's here, this is going to hang down to somewhere here. And so we'll have, let's use another color. We'll have this hanging down, and it would be something like the point 0, -12. Okay, so now they tell us that it's traveling at a rate of 3 radians per second. So what we need to know is, first of all, in my other video I talk about this, on your unit circle, 3 radians ends up being somewhere over here because this is pi, which is approximately 3.14. So it's a little bit shy of that. Okay, so we need to set up a relationship here. So it's 3 radians is to 1 second as 2 pi radians is to x. Well, we don't know the time. Okay, so when I cross multiply, I get 3x equals 2 pi. Therefore, x would equal 2 pi over 3. So that means that the time that it's going to take to go entirely all the way around the circle is 2 pi over 3 seconds. So this at time 0 is right here. Then this one was at time, well, then we get back again at time 2 pi over 3. You know what? Let me use another color to show the time. Okay, so then when it's, so at 2 pi over 3, it's all the way back. So that means half of it is when time is equal to pi over 3. And then we also have, so then half of that would be this point that I'd labeled here. And so that would be at time pi over 6. And then this one down here is going to be, well, 1 pi over 6, so it's 0, it's 1 pi over 6, 2 pi over 6, 3 pi over 6 is pi over 2, and then 4 pi over 6 is that. Okay, so this would be pi over 2. Hopefully you watched that other video. If you haven't, pause this and go watch it, because it gives you a little bit more of an idea of what you need to do. What shape will the graph of point E be? Is this a simple harmonic motion? Yes. So you could say it's, well, it's sine or it's cosine, depending on how you want to write the equation. So what we have here is at time 0, here's what I'm looking at. At time 0, we have a height of negative 10. So at time 0, I have a height of negative 10. Then it's going to go up and then come back to that, back to negative 10, down to negative 12, and then back. That's a sad looking curve. I'm so sorry. I do better when you're not watching me. Okay. Sketch a graph of, so this is the point, what did we say? 0, negative 10. This point right here, we said was the point pi over 6, negative 8. This right here is the point pi over 3, negative 10. This is a mess. I'm so sorry. This is the point pi over 2, negative 12. And then we come back to, wow, okay, hang on. For some reason, I don't write well on the edges of my screen. Whatever. Do other people have that problem, or is it just me? Well, anyway, it is what it is. Okay, so those are the points that we care about. So find the period. We already did. Okay, so this was up here when we said, well, how long does it take, if it does 3 radians in 1 second, how long does it take it to do the whole rotation? And that was 2 pi, so it took it 2 pi over 3. So the period is, well, 2 pi over 3. What is the value of b? Okay, so 2 pi over b is going to be equal to that 2 pi over 3, therefore b has to equal 3. What is the amplitude? Well, on amplitude, we want to know from this midline to the top, how far up did we go? Well, that was 2 units. What are the coordinates of E to start with if the rod is 10 units long? Well, what did we say the coordinates were? 2, negative 10. I guess that's what they want. Write an equation for the graph of point E. Okay, so we know that, let's do it, the height as a function of time. So I could call it f of t, I can call it whatever I want, but that's what I'm thinking. When I write h of t, I'm thinking height as a function of time. And so it has an amplitude of 2. This looks a whole lot like a sine curve. And then my b value is 3. I didn't shift left or right. Oh, I've been doing this. I've been writing x instead of t, but I correct it most of the time. My bad if I don't. And then we have to subtract 10 to move down. Okay, use the equation to find the first time that the tip E of the rod will be at a height of negative 9. Okay, so this one is saying, okay, when h of t is equal to negative 9, solve for t. Okay, well, this is 2 sine of 3t minus 10. Add 10 to both sides. I'm sorry, I don't have enough space here, so, well, add 10. I have 1, and then divide by 2. 1/2 is equal to sine of 3t. This is something you know from the unit circle. So on this problem, I would expect you to be able to keep going without using a calculator. Often we'll see this question, use the equation to find when it is at a height of negative 9 within the first rotation, is how they ask it on the homework. I just worked the homework. So what you want to think about is a height of negative 9 is going to be here and here within the first rotation. So, right, because this is negative, oh, here in the middle and there in the middle. Okay, because that's negative 8 and this is negative 10. So it's gonna hit that. If this goes on forever and ever, it's gonna hit it infinitely many times. But we just care about within the first rotation. Sorry, this is bothering me. This is all that problem. Okay. Then we know that the height, we know the sine equals 1/2, at pi over 6. And we also know that, well, okay, now I wrote this and it's annoying me. We also know that 1/2, I lied. That's not what I wanted to write. I'm so sorry. I have definitely done better videos. We know it happens at 5 pi over 6 also. So really and truly, the reason I'm doing this is because it shows up in your homework. This right here is the answer to the question. So let's finish. We need to divide both sides by 3 or multiply by 1/3. So time is equal to pi over 18, or here, time is equal to 5 pi over 18. And so that's going to be when that happens. Here, oh. This is all that problem. Okay, what a mess. Now let's look at this next one. So here's this one. What will the height be at a time of 5 pi over 6? So we're saying, okay, h of 5 pi over 6, let's plug in that for t. Well, our equation was 2 sine of 3 times 5 pi over 6, minus 10. Okay, this is 2 times, well, this is what? 3 can cancel with a 6, giving me 5 pi, I forgot to write the rest of it. Sine of 5 pi over 2, that's a 2, minus 10. 5 pi over 2, when I think unit circle, I think 1 pi, or pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2 is right here. That sine value is 1, so this is 2 times 1 minus 10. That's negative 8. If you think about it, at a time of 5 pi over 6, well, that's going to be, if we come back to this curve, here's 0, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6 is going to be at the top again. So our curve here matches what we would expect to see here. All right. Hopefully, well, go watch this video. I made that one a few years ago, and then I will make this video in just a second. All right, good luck. Go practice.